Okay, so this is the additional video where I'll show you how to use this circuit applet to hopefully build up some of these circuits. And you can use this mostly just sort of as a tool to kind of play around with things. You could use it to actually evaluate truth tables to be able to see if you don't want to if you don't want to think about it. You could build it up and then try the different true false cases. You're using the applet actually. But mostly this is just to sort of get a better sense of physically um, what are these things actually made of. And anyway, so this is the last slide from the lecture from this week. So just click on this link, or if I put my mouse over it, I guess for a minute, that's the website that it's going to take us to. There's lots of little applets that people have made in order to build circuits. So this is one such example of many that I thought actually sort of had a neat interface. So let's when we click on this, we'll try to maybe do at least some of these examples, just so you can kind of play around with things. So I'll click on this. And hopefully, okay. Um, let's see. So here it should take you to something that looks sort of like this, I hope. Um, which this is called a logic lab. These are mostly made by educational universities or some other sort of educational outfit. So anyway, it's very easy to use. So what we're going to build here are some of these circuits to sort of see them in action and see what might really be um, happening with these guys. So there's a lot of features on this that we won't use. That this is used for like much fancier, I don't know, crazy, real sort of physics or electrical engineering types of applications. So, okay, so we'll just be much simpler with our circuits. So, um, we're mostly just going to use a few things from this menu on the left here. And this just works just like sort of puzzle pieces. So, from the input tab, I guess, there's a variety of types of input you can do. We're just going to, I think, pretty much exclusively always grab this one. So I just clicked on that and dragged one of them over. Maybe I'll drag another one of these inputs over. And what these are just light switches. So as I was mentioning before, if you click, right, these will switch from off to on or on to off. Uh, so these are just going to be our examples of maybe A. Maybe this will be proposition A, and this will be proposition B, which are either true or false, right? So they'll either be off or on, depending on how we throw the switch, literally. That's pretty much all we need to grab. And if we need more of them, we can just come back to this menu and grab another input. Obviously, we're going to use logic, these logic gates. um, which here you can see the ones we talked about. The AND gate is here. They don't use the same shapes, so sorry. I don't know why this app doesn't. These are all just squares. So, but it says what it is on here, right? So the AND is here, the OR is here, the exclusive OR, and the NOT. They're all here. These other three are just sort of combinations of these abbreviated. Like this is the NOR is OR, but all opposites. NAND is AND, but all negated. So in other words, all the opposites. And this is the negation of exclusive OR. We don't need to overcomplicate our lives and make them even crazier, so we'll just stick with the four that we need. And you grab these just like you normally would. So if I grab maybe the AND, for example, you can grab that and put that here. Now what you'll notice is that our inputs here have little, I don't know what you want to call that, but in the physical world, this is a wire that you'd be able to say, okay, here's a switch, a transistor that's off, that's either off or on, that you can toggle. And there's a wire coming out of it that's either going to be turned off or on. So if I click and drag, you can connect, and notice it turned green when I got close to this input. And if I let it go, obviously this pretends that you've connected the wire of the output of this light switch to the input of this, one of the inputs at least, of this AND gate. Right? And you can see, of course, there's two inputs. So I could hook them both up, of course, if I grab this one and click and drag. As soon as it turns green, I'm close enough and I can let it go. And it'll say, okay, fine, I'll connect that wire there as well. All right, so these are both connecting into an AND gate. And if you play around with obviously turning them on, so the red is on, which the other thing you can notice is, of course, is that the wire turns on as well, right? So this is off, so there's no electricity here. But if I turn it, then there is, right? So now electricity is flowing in both, and on meaning true, right? So this is the example of true, true, which is both feeding in. Now, I don't know what it's producing, though, because I don't have anything over here in order to sort of receive the signal, so to speak. So another thing I might do, turn these off for a second, is grab, also from the menu down here, an output device, I guess. And there's a variety of ones you can pick for this, but I'll just choose the easiest example, which is just a simple light. So I'm going to grab this guy here and put him sort of somewhere over here, I guess. Maybe I'll move him over a little bit more. And this is just going to turn on if what it's receiving is true, and off if what it's receiving is false. So if I connect my AND gate now, just like I did before, drag it and let it go, this is now a circuit. So this is saying you have power sources, they're flowing into a gate, and the output of the gate is either yes or no, or true or false, and that's going to be given by the light that's here. So right now, these are both turned off, so these are both false. And for an AND gate, I know that the only way that an AND gate is true is if both inputs are true. So right now, if I flip that guy, it's true. I have one true and one false. So of course, the output is still false, because the AND is only going to turn on if they're both on, or if they're both true. And my light here is off. But if I flip this switch, first of all, electricity now flows out of this, meaning AND is true, or the AND result is yes or true, and my light also came on. Right now, if I turn either one of them off, the circuit is dead, right? Or in other words, I get false over here. If I flip it back on, now it's true, right? Okay, so this is what I mean. It's kind of fun just to sort of play around. But this physically, obviously not these little cute pictures, but with wires and whatnot, is what is in your computer and in your phone right now. Are these transistors corresponding to different things, and some gates, some logic gates, and then some, now it's not a light switch, it's a, okay, now I do this thing. Right, this is what I'm sort of simulating here. Okay, so these are both yeses. Oh, do that thing now. Do that thing now. Do that thing now. And then when one of them turns off, oh, stop doing that thing. Stop doing that thing. Okay. So, yeah, so maybe just a quick look at some of these examples, right? So, the dollar sign, for example, if I wanted to make the physical circuit for the dollar sign, how do I know that a dollar sign should be turned on, or a dollar sign should be happening? Well, I do need an and here, right? Because I do need to say, how do I know to make a dollar sign, is that I would hit, if I said that this guy up here maybe is the for key, right? So unfortunately you can't label in this. It would be nice if you could. So we're just going to have to you're going to have to kind of remember or think as you're doing these, wait, what is what here? But if this switch, let's say, this transistor here, let's say that's the for key, right? So it's either pressed or not pressed. Right now it's not pressed. And this guy here is maybe a shift key, right? Then I think I actually already have the circuit for how to know when should I make the dollar sign, the dollar sign, right? Because how do I know to make a dollar sign? Well, right now I'm not making one, because again, remember, this is the for key, which is not being pressed. And this is the shift key, which is also not being pressed. And even if I'm going to do this on my keyboard, you can't hear me, but I'll do it loudly, right? If I press the shift key, right, this is on, right? I'm hitting the shift key. But of course, I'm still not getting a dollar sign because I'm not doing both things, right? And I can press the for key. that turns that on, but still no dollar sign, right? But if I do them both at the same time, which I don't have two hands free, so I can't do it, but if I was to hit them both at the same time, it would say, yes, dollar sign, dollar sign, dollar sign, make it rain, lots of dollar signs, right? So this circuit, the AND circuit, is actually, which we just did sort of just randomly in order to get our feet wet, would be a perfectly good circuit for the dollar sign. Now, if you really were being professional, I guess I would say, about this, I'm not quite telling you the truth, am I? Right? Because isn't it true that in order to make a dollar sign, I could hit the left shift key or the right shift key, right? So let's try to be maybe a little fancier about this and say, how do I know when I'm supposed to make a dollar sign? Well, I need the 4 key, right? So I'm going to still call this switch the am I pressing the 4 key? That's still this guy. That's got to be on, right? In order for me to make a dollar sign, I have to hit the 4 key. But I think I have options as to how I might create shift, in other words, right? I could get shift by doing the left shift key. Let's call this switch the left shift key. Or I think I could also get by and make a dollar sign if I hit the right shift key. Isn't that right? So why don't I pull one more switch, one more input switch into our picture and say, this switch now, let's call that the left shift key. And this switch down here, let's say that that's the right shift key. In other words, am I pressing it? Then I think I don't really want that. So I just clicked on that to kind of make it go away. I think I would want to say, how do I make a dollar sign? I need the number 4 key, has to be pressed. But as long as either of these is pressed, I think that would still make, then I'd want to say, okay, that's when you make the dollar sign, right? So I think I need this to be true. I need to hit the 4 key. And I need to have either of these, right? So I just said the word or. So why don't I maybe grab an or gate? I don't think it's exclusive or. I think you could probably hit both shift keys, and I think it would still probably do it. So I'm just going to grab a regular or. If you know more about this than I do, then maybe I needed a different exclusive or. But I think just regular or is okay. Let me move this guy over a little bit. There. So I'm going to insert an or here and say, all right, that's the 4 key. That's got to be present. But this is the left shift key and this is the right shift key. So as long as either of these, or maybe even both of them, is on or pressed, I would then say, okay, as long as one of them is on, either or, that should be a yes. And then for my and is just then saying, all right, is the 4 key pressed? And is either of the shift keys pressed? So I think this circuit might be a little more accurate in terms of when do I make a dollar sign? So I need that to be on. And then if I hit the left shift key, this lights up. It says, yes, I should make a dollar sign, right? Or if I hit the right shift key, that was our second switch down here, I also get yes. Yes, you want to do that. You want to make the dollar sign. And I think, maybe you'd have to test this, but I think if you hit both shift keys, which requires a lot of dexterity, and the 4 key, I think you also get a dollar sign. If that's not true, then you'd want to replace this or with an XOR, right? An XOR would say only if one of them is true should you be turned on. Okay? So this is a cute little circuit. Again, it exists, I promise you, that it exists in your computer. And this is how it knows, right? Is that it has, these are the little switches that are behind the left shift key, the right shift key, and this is the switch that's under the 4 key. And these are literally wired up in this format. And rather than a light shining, the dollar sign is what will appear when this is all connected, right? I should have done one more little test here, right? If I just do a shift key, right, left shift key, I'm hitting that. Or if I hit the right shift key. nothing happens, right? I don't get a dollar sign because I have to add in the 4 key in order to turn this on. Okay, so that was maybe somewhat interesting. So that's the dollar sign circuit. How about capital G, the capital G circuit? So I'm going to recycle. Obviously, you could just reopen this and do a new circuit, but I'll use the fact that I think we can maybe recycle some of this. To make a capital G, I certainly need the G key to be pressed. So I'm going to call this switch now the G key, right? And how else do I make, how do I get a capital G? Well, I need to be hitting the G key and some sort of mechanism that says, capitalize me, right? I need to be able to say, all right, you make a capital letter. I know as a human being that means I need to maybe hit a shift key. Or I could hit the caps lock key, isn't that right? I think I could do that as well. So let's see, I'm making my life a little more complicated, aren't I? So let me move this guy over and say, all right, this is the G key. That's my switch to, am I hitting the G key or not? That's got to be on in order to make a capital G. But now I think as I'm thinking down here, I have options for how I might consider the capitalization factor. I could stick with what I have from before, which is to say left shift key, right shift key. And for sure, if I hit the G key and either of the left key, shift key, or the right shift key, I think I do get a capital G. But this doesn't allow me to hit the caps lock key, which is also, of course, a possibility. So let me grab a switch, one more switch, and I'm going to call this guy the caps lock key. Okay? So I know this would be better if I could label these things. So one more time. This is, am I hitting the G key? This is the left shift key, right shift key, caps lock key. Okay. Or in other words, is the caps lock on or is the caps lock off? Right. So let's see. I think when we were doing this earlier, we discussed maybe that in order to make a capital letter, I think you need either one of the shift keys has to be on, or the caps lock key could be on, but not both. Okay, so let me disconnect this guy for a second. And I think, if I think about this logically, what is it I'm trying to say here? I need the G key, but I also just need one of these guys to contribute the yes, I want a capital letter right now. So I want to say, all right, either the left shift key or right shift key, or both of them, I guess, could be pressed. That would work. Or, exclusive or, the caps lock key could be on. And if that's true, I want to also make a capital G. So see if this makes sense, right? So let me grab an exclusive or. I'm going to put it sort of there. So how do I know if capitalization should happen? Well, I could hit the left or right or both keys. That's one possibility. Or I could hit the caps lock key. So if I feed these two guys into an exclusive or, then what's going to happen? So remember, exclusive or is yes, or is turned on, when one of the two inputs is on and one of them is off. Okay? So I think this should work, right? So exclusive or will be turned on. So notice what I could do here. If I turn this on, this is the caps lock key. Then exclusive or, I know you can't see it, but is going to say yes. It's true. Now, if they're both true, which is maybe this would be me hitting the caps lock key on and hitting the right shift, exclusive or is actually going to be turned off. But I think that's sort of what we want here. Okay, so let me turn my switches back off and let me connect this guy. Okay, good, right? So I think this might work, right? So how do I make a capital G? I have to hit the G key, that has to be on. But right now, I'm not making a capital G, because and requires both things be on. So I'm going to say, all right, so for this to turn on, this has to produce on, or true, exclusive OR is true when one of the inputs is true. So let's see. If I put caps lock on and I hit the G, I should get a capital G. So let's see. I do, right? So if I hit the caps lock key is on and I'm hitting G and I'm not hitting shift keys, then yes, make a capital G. Okay? Or I could hit maybe the right shift key or the left shift key. If I do that, I'm good. If I hit the right shift key, I get a capital G. If I hit the left shift key, I get a capital G. And actually, even if I hit both shift keys, I still get a capital G. Okay, since I don't have a million fingers or a million hands, let me turn that off and say, all right, but what happens if I have the caps lock on and I hit the left shift key? I think what happens is you actually end up with a lowercase g. And I think we did this correctly, right? Because we said, all right, if you happen to have caps lock on and you hit shift, then exclusive OR has both of these things being true, which means this turns off, or it's false. And the and is going to also be false, because I don't want to make a capital G, or I don't make a capital G when I sort of do overkill here, which is caps lock plus shift key. So I think this is good. So I think we've got it. I think we've got our circuit here. That this seems to make sense, right? So if I've got my 4 switches now, my 4 propositions, this is the G key, these are my 2 shift keys, and this is the caps lock. This exactly is the circuit that should work in order to say, when do I make a capital letter? All right, so that's pretty good, I think. And in terms of the logical sentence here, I guess, this is a little bit messy, I guess, but if I think about this as A, B, C, and D, then I have A and then what is all this business? Well, this is B or C XORed with D, and that's all ANDed with A. Okay, which is kind of a mouthful, of course, but that should be the circuit more or less that exists, again, under your keyboard or in your computer, that is the capitalization. Now, of course, there's obviously other keys other than G. All of those guys have their own circuits, though, right? Is to say, okay, how do I make a capital W? Well, this gets replaced with is W pressed, right? But these all correspond to the capital letters. Okay, so what else do we want to do? Maybe I won't do all of these because this takes a while. So for making ones where you have the sort of formula, like these guys here, you're just sort of mostly just constructing and maybe experimenting a little bit with, do these produce the outputs that you expected them to? So maybe I'll do the last 2 here. So how about not A, XOR B? So let me do this one. Okay, so I don't need all these inputs. I'm just clicking and dragging them over to the side, which just sort of deletes them. Okay, but I'll leave my 2 inputs and my output over here. So I've already forgotten what I was supposed to do. Okay, not A, exclusive OR B. Okay, so I'm going to try to form the circuit for that, which we did in the lecture video, and we discovered, I think, the true-false stuff for that. But let's pretend we didn't do it, and I'm just going to make this circuit. Okay, so not A, XOR B. So not A, XOR B. All right, so I'm going to grab an XOR. And that's sort of the main guy, so I'm going to sort of put that closest to the output maybe. But it was not A, XOR B. So let me grab a not. And I'm going to not just the A, so I'm going to sort of put it maybe up here. All right, so this is A and this is B. These are my switches. They're both off right now. So if I want to form this circuit, I think I don't know what else to say, right? I'm doing not A, and that's being fed into an exclusive OR with B. Okay? So, right, let me just make sure I did the right thing, right? Not A, and then that's exclusive ORing, that's not really a verb, with B. So I think that's what I build here, right? Not A, so this is A, and then it's going to be flipped to not A. And then this is B, and those are going to join in an exclusive OR. And that's what I'm going to connect to my little light out here. Okay, so oops, let me connect that guy. All right, so when is this circuit true and when is it false? Well, right now I'm starting with they're both off, right? False, false. So A and B are both false. So of course A is false, which means it's not on. But remember, not switches you. So it was false, but now it's true. So it's green, it's on. This is false, so it's off. But remember, exclusive OR is going to be true if one is true and the other is false, which is what I have here. And so, of course, our light is on because this is saying yes. Do whatever this is corresponding to. I don't know what this is corresponding to, but whatever action this is would say, yes, do it. When you have off, off, or false, false, yes. Okay. If I flip this guy to on, look what happens. So I flip this A switch to on. Now the not of that is off, which means these are both off. And so, of course, do I have or? Is this or this on? No. So it's off. Okay. All right. So if I flip this guy, right, if I do the opposite, which is to say off on or false true, then what happens? So A is false, so not A is true, and B is true, so these are both true. But remember, exclusive OR just wants one true and one false. So it says, no, I'm off right now. Okay, and I think our third case is what if they were both on? And if they're both turned on, then this NOT gate flips it and says now it's off. And if B is true, then again I get the one true and one false, which exclusive OR says yes, I'm on. Okay, so this is another way, if you didn't want to think about it, I guess, that you could say that truth table that we made in the lecture video. I think we investigated that truth table, and I think, if I remember, the conclusion that we made was that when the two switches are the same, that's when this is on. And when they're different, that's when this is off. And I think we just confirmed that, right? When the switches are the same, on, it's on. Or if they're off, off, it's also on. But if they're different, one off, one on, no. Or if it's the other combination of off and on, no. Right? So this does a pretty good job of confirming, hopefully, that our truth table that we made in the lecture video is correct for this guy. All right. So maybe I'll just wrap it up by doing one last one, which is maybe the last example here of A or B and C. I should have probably done these examples first because they're way easier than these guys. But anyway, so A or B and C. Okay, so let's see. So let me get rid of all my guys here. So I need three inputs because I have three propositions, A, B, and C. Okay, so A, B, C. So I want to do A and B and then ORing that with C, right? So just grab your gates that you might need. So I got to AND these two guys, right? A and B. And then I'm going to send that result into an OR with C. So I'm going to maybe just sort of put it there. All right, so I'll hook these guys up. So A and B are going to go into the AND. And then the result of that gets fed into an OR with C. Okay, so again, I'm not sure what else to say aside from you're just pretty much translating from, symbols, I guess, into, or, letters and whatnot into symbols, into the circuit. Okay, so let me connect this to my light over here so I know when it's true or false. And now I can play around again with sort of the combination of trues and falses for my three inputs now, right? So I'd have 8 cases to check of, when is one true and when is one false and all those different combinations. And I could use this to investigate, okay, when is my sentence or when is my statement true and when is it false? Okay, so just to play around with it a little bit, I won't do all the cases, but as long as this switch is on, then this is going to be on. And remember, OR just wants one of them to be on, and they can actually both be on, and it would still be okay. So at any time I have that switch on, I don't think it matters what I do up here, right? I could do this, I could do this, I could do this, I could do this, this. Whatever I do, all four cases of up here, I end up with, it's always on. Why? Because this is on. And as long as this is on, the OR of this stuff and this is a yes. All right, so let me turn that guy off so that that doesn't ruin my fun here. So if I turn this guy off, now the only way that this is going to work is if this guy is on now. And this guy is on only if both of these, remember the and says both of them have to be on. So if I just turn one of them on, no. If I turn the other one on, no. So the only way I'd make this guy activate is if they're both on. So if I do on, oh, now I do get electricity to flow all the way to the end. And in fact, if everything is on, I'm also okay. Okay, again, if for an OR, they could both be on. If this was an exclusive OR, I'd be off right now. Okay, so I'm going to go back to the slide for a minute, right? So you play around with this, right? It's mostly just sort of a toy, I guess. But it is sort of nice and it is sort of useful to be able to kind of visualize what's actually happening. And even though this is just a little play app or applet, this, again, in reality, in the logic sense, this is exactly what's actually happening in your computer. And this electricity, which we're seeing here in green, flowing or not flowing, is really what happens. So, okay, so hopefully play around with this guy a little bit, and feel free to use it to answer some of the questions in the homework. It doesn't really have a great save feature. It does let you try to sort of save what you've made, but it doesn't let you save it like to your computer or anything. It saves it as like a web link or something, so it's kind of goofy. So anyway, if you ever do want to sort of save one of these, you could always just take a screen grab of whatever you've constructed, or just take a picture of your screen with your cell phone or something. In the homework, I'm asking you to do everything just sort of on paper. So if you said, okay, I'm happy with this circuit, this is the circuit that I wanted to build, just copy it down on paper, and that would be perfectly fine. Okay, so enjoy.